Hey guys, Mr. Backberg here. In this video, we're going to look at similar triangles. Now, as we're talking about similar triangles and really similar figures in general, there are two properties that make shapes be similar. And the first property is that corresponding angles are congruent to each other. And the second property is that corresponding sides are proportional. And we'll talk about what both of those mean as we look at a picture of a couple of triangles. Now, in this picture, we've got two triangles, and they're definitely not the same size, but they are in fact similar to each other, and I've oriented them the same way. So they're not reflected and they're not rotated. That's going to make it easier to talk about what it means for these triangles to actually be similar. So we can see that angles A and D are corresponding because they're in the same position. Angle B and angle E, those are corresponding because they're in the same position, and C and F are corresponding because they're in the same position. Now, our first property that we just looked at on the last slide said that corresponding angles are congruent to each other. So in order for these two triangles to be similar, angle A and angle D need to be exactly the same size. So if angle A is a 30-degree angle, then angle D needs to be a 30-degree angle. Those two angles need to be the same size. Angle B and angle E need to be the same size because they're corresponding. So if B is 100 degrees, then E needs to be 100 degrees. And then lastly, angle C and angle F need to be congruent to each other. So if C is a 50-degree angle, then F would need to be a 50-degree angle. So there, all three sets of corresponding angles are congruent. So that satisfies the first property. Now, the second property deals with the sides, and it said that corresponding side lengths are proportional. And when we're dealing with proportions, we're making fractions. And a proportion is saying that two fractions or multiple fractions are equal to each other. So side AB and side DE are not going to be congruent to each other, but what we're actually going to do is make a fraction, and I'm going to put AB on top, and I'm going to put DE on the bottom. Now, when we make that fraction with that set of corresponding sides, that fraction needs to be equal to the fraction if we take another pair of corresponding sides. So say we take BC and EF. To be proportional, these fractions need to be equivalent. And similarly, if we went with our longer AC side and that DF side. So when we make these fractions, they all need to be equivalent fractions. Now, we can use properties of similar triangles to help us do a little problem solving with similar triangles. So here we've got a similar picture, but I've added some lengths to those sides of the triangles. So in that triangle on the left, we've got 16, 24, and 32 for those lengths. In our triangle on the right, we only know one of the lengths. We know from D to E is 8. But we're going to use what we know about these two triangles being similar to each other to help us find these two missing sides. Now, the big property that we dealt with the sides was we said that they were going to be proportional to each other. So when we build fractions out of the corresponding pieces, those fractions need to be equivalent. So what I can do is I can set up a proportion using two sets of corresponding sides. So because I know AB is 16 and DE is 8, I'm first going to make that fraction. Now, let's look at this BC side. We know that BC is 24, but from our other triangle, we don't know how long that corresponding side is. We just know that it's x. So I can put that x on the bottom of this fraction, and then I can use what I know about solving a proportion to help me figure out what that x value is. When we've got an equation with fractions on each side, we're going to do a little cross multiplying. So I'm going to take the 16 times the x to get 16x. And then I'm also going to take the 8 times the 24. And when I do that, I should get 192. Now, if I want to get x alone, I'm just going to divide that 16 over to the other side. So then we should get an x value of 12. So this EF side right here, we just figured out was going to be 12. Now, I also want to find this DF side with that y value in there. And I'm going to do similar to what I did before. I'm going to use the two sides where I know both of the lengths. So AB being 16 and DE being 8. So I'm going to go 16 over 8 equals, Now, if I want to find y, its corresponding piece from my other triangle is that 32. So I'm going to go 32 over y. Now, because I've got this equation with fractions on each side, I'm going to cross multiply again. So 16 times y is 16y, and 8 times 32 is 256. Now, if I divide that 16 over to the right-hand side, then we should get a y value of 16. So this long side from this triangle is 16. So that's how we can use that side length relationship with similar triangles to help us solve to find some missing sides. That's going to be it for this video. Thanks for watching.